All right, so we are going into chapter 11, new unit. So chapter 11 is about geometry. So we are going to go ahead and get into that right now. Let me share this screen with you. Let's go ahead and get this rolling. Get here. Almost there we go. All right, so introductory geometry. One things I do want to kind of stress to you guys is that when we get to geometry, just understand your kids, your students, some of them will really love geometry, some of them will not. Some of them love both math and regular old math and geometry. Some don't like either. So, it is a thing that, geometry does work a different part of their brain. Um, and so sometimes some kid that isn't very good in some of your other math things that you're learning will really excel at geometry and vice versa. So don't get frustrated with that. Just understand that is very, very common. All right, so we're going to be starting off with talking about the undefined terms. Kind of go through a few of those, and then some attributes, properties, names, classifications of angles, a lot of definition stuff. So we're going to first start off with your three undefined terms. So when we look at this, we have point, okay, line, and plane. Those are your three undefined terms. And the reason why they're kind of undefined is because A, it's almost impossible to try and find the words to perfectly define it. And the fact that they're just mostly mental images. Okay, a point, a line, a plane do not have depth. They don't have width. A line and a plane go on forever. Okay, they don't have any depth. A point itself doesn't have any depth or size. It's just a location. Okay, so as you look at these things, that's what makes them undefinable. Okay, so as you notice, here we have point A, point B, and point C. Okay, notice they are capital letters. A point always uses a capital letter. Okay, line. Okay, now lines can be different things. So here we have this line. Okay, center of the road. Okay, notice line L, and it's cursive. It's lowercase cursive. That's one way we describe a line. Now, so this one here is line M. Okay, lowercase one letter. Okay, now we can also say it's you can have line, say the word line AB, and it uses 2 points to describe. A and B, remember capital letters are points. You can use this symbol, line AB, with the 2 arrows. Okay, it has an arrow on this side because a line goes on forever and ever and ever, will never end. Okay, don't confuse it with a segment. Okay, segment's different. Okay, and then you can reverse the letters. It doesn't matter what order it goes in. Okay, so different ways you can label a line. And then labeling a plane like it's top of the tabletop. Okay, it goes forever in both directions, and that way that. Okay, so it's going to go in all directions. Okay, never ends, but it has no depth. Okay, notice sometimes they'll use a Greek letter in a corner. It's always in the corner of the plane. Okay, here's another Greek letter right here for this plane. Now, to name a line, we might use 2 letters, but to name a plane, you have to use 3. Now, this is line A, B, C, or line, the Greek letter, whatever, alpha up here, okay, gamma, whatever you want to use it, okay? But when we name a plane, A, B, C, those three um, points, A, B, and C, cannot be on the same line. A, B, C, notice C is not on the line of A, B. Okay, so all of those have to actually apply. Okay, all right, so this is why, let's talk about why they are undefined. It says line. The line has no thickness and it extends forever in 2 directions. Given any 2 points, there is one and only one line that can go through those 2 points. In other words, it doesn't matter where you draw the 2 points, there is only one particular line that goes through those 2. Okay? Let's see here. Got to get that back out. All right, so if P and Q are any 2 points, we can create a number line on that line PQ such that there is a one-to-one correspondence between the points on the line and the real numbers. This says that you can take 2 points and make a number line through those. Okay, linear notations, we already talked about this. Line L, lowercase, contains point A, B, and C. They are what we call collinear. Okay, there's your term, collinear. Okay, so in collinear, you have to have 3 points that are, because any 2 points can make a line, you have to tell 3 points to make them collinear. Okay, points A, B, and C have to belong on line L. Points A, B, and C are collinear term, and points A, B, and D are not collinear, or they are non-collinear. Okay, now what does that mean? Here's A, here's B, which any 2 points can make a line. Here's D. Now I can make a line through AD. I can make a line through BD, but you cannot make a line through A, B, and D at the same time, which makes them non-collinear. Okay? All right. So, term that gets really misconstrued in geometry is betweenness. Okay? So, if you look at this line L, the point B is between A and C. Okay, it is on line L, and it is between A and C. But that does not mean it's in the middle. Okay, point B could actually have been here. Could have put point B here. You could put point B here. You could point B over here. Okay, as long as they are between A and C somewhere. Point D is not between points A and C. Point D is non-collinear too. So something non-collinear would not be able to be between either. Okay, but there's often misconstrued. Between is not mean middle. Could, but not necessarily. Okay, segment. Now the difference between a line segment and a line. Okay, a line segment is closed. Okay, it is part of a line and contains 2 points of the line and all the points in between. Okay, so a segment ends. It does not have the arrows. Okay, if we put arrows on there, then it becomes a line or array. So this would be line AB if I did this. Okay, but the segment itself is just part of it, and it contains the same as line AB between A and B. Any points in between A and B. Now, how do I different? Look how we have here. There are no arrows on this line up top. Okay, notice there's no arrows. Okay, actually I should do it this way. Oh, hold on a second. Let's just do it this way. Okay, I can do it. Hold on a second. Yeah, I'll do it later. All right, so let's go on. All right, open and half, half open and half closed. All right, all that means is AB is a segment, and at one of the endpoints, one of them is open and one of them's closed. Notice here A is open, B is closed. Here A and B are both open. This is an open segment. This is the top one, AB, with one open circle is a half open or half closed segment. Okay, it just means that endpoint doesn't actually part of the line. Okay. A ray. This is a subset of line AB and contains the endpoint A and the point B all belongs between A and B and all the points C on such a line that B is between A and C. All right, so a couple things. A ray has to have an endpoint. Okay. A has to have an endpoint right here. Okay. It also has to have an arrow over here. Okay. So as we go, okay, as we go from here to here, okay, we call this ray AB. It is part of line AB. Notice here's line AB, but AB is my ray. And the first letter always is the end point, not the arrow point. You must start it with the N. Okay? Then we have what's known as opposite rays. This says that ray BA. Now this would be ray BA, this way here. Okay? Then you have ray, hold on a second. And then we have BC. So BC would come this way. These are opposite rays because they share the same endpoint. Okay? If we look at the endpoint, here is B. They share that same point. As long as they share that same point, you will have opposite rays. They go in opposite directions. Okay? So more terminology for you. All right, a half line. I'd hardly ever use the term half line. I don't know how many people actually teach a half line. It says a half line is a ray without endpoints. Okay, so you take two rays going in opposite directions, and then the endpoint is open. Okay, but it's very used very rarely. This might be more because it's not a Texas textbook, basically. All right, planes, coplanar. We talk about a plane. It takes 3 points to make a plane. Points D, E, and G are coplanar. Okay, D, E, and G, they are on the same plane. Okay, so the thing is, you must have, to show coplanar, you actually have to have 4 points. Okay, notice D, E, F, and G are non-coplanar. Well, what makes it non-coplanar here? F up here is not on the plane. So it cannot be coplanar with these three. Now, here's the thing. You can make any 3 points coplanar. Okay. Now, lines DE. Okay. Well, here is line DE. Oops. Didn't hit that. Here's DE. That's on the plane. DF. DF on a plane. And FE. Now, the thing is, any 3 points are coplanar. Notice how many points I have. D is a point, E is a point, F is a point. 3 points make them coplanar. Any 3 points can be coplanar. Okay? Lines DE and EG are coplanar. Okay? DE is on the plane and EG is also on the plane. Lines DE and EG are intersecting lines, which means they intersect in a point. Where do I know that point is? It happens to be here at E. Okay? So, intersecting means that point they have in common. All right, skewed lines. These are one of my favorite terms, a skew line. Lines GF and DE are what's known as skew lines. They do not intersect, but they are not, there is no plane that contains them. Okay? I've heard it defined as they are lines that do not intersect and are not parallel. I think it's a better term. Okay? So, if we take GF, let's go look at this. Here is G to F, right here, this line right here. This line right there. And DE, this one here. Notice they do not intersect, and there's no way you could put those two on the same plane, which makes them skewed. Okay? Concurrent lines. Lines DE, EG, and EF are concurrent lines. They intersect at one point E. So if you have lines that intersect at a certain point that are all intersect in the same spot, they're known as concurrent. Parallel, you probably remember this one. Parallel lines do not intersect. They have no common points. The symbol for parallel is the 2 bars. Remember, lines are lowercase cursive. So here's lower M, lower N. So line M and N are parallel. They do not intersect. All right. Axioms, points, lines, and planes. It says there is exactly one line that contains any 2 points. We already talked about that. If 2 points lie in a plane, then the line contained in those 2 points are also in that plane. So that would make them coplanar. If 2 distinct planes intersect, then their intersection is a line. That is an important one. Okay? Think about this. 2 lines intersect at a point. 2 planes intersect at a line. Okay? Think of a wall and a ceiling. If you looked at a wall and a ceiling, look where they intersect. It forms a line where they intersect. There's exactly one plane that contains any 3 distinct non-collinear points. That's what we talked about a little while ago. Okay, I already kind of stated that any 3 points can be considered coplanar. Okay, they're on the same plane. Okay, now we want them to be non-collinear points to prove that they're coplanar, though. All right, a line and a point not on the line determine a plane. Now, the reason that works, okay, it says a line and a point determine a plane. That's because any line has 2 points. But I need 3 to make a plane. So I have 1, 2, and 3. And that is why that works. Okay? 2 parallel lines determine a plane. Okay? Any 2 parallels can be in the same plane. Okay? Again, the reason that works, if this is parallel and this is parallel, I can draw a plane that goes through both of them. Okay? 2 intersecting lines determine a plane. Okay? Don't use that one too much, but it is possible. Ooh, let me do this. Let me clear this out real quick so we can see this one. Oops. There we go. All right. So plane alpha and plane beta. Notice they are parallel. They do not intersect. But if 2 planes intersect, here is that line that they form. Okay? Half plane. A half plane is a subset of a plane that consists of all points in the plane on one side of a line. So you can take it this way. If you want to talk about a half plane here, you're going to have the half on this side, and we're going to have the half on this side. That would make them half planes. All right, now let's talk about angles. Okay, so an angle is formed by 2 rays. Well, here's my ray BA and my ray BC. These are my 2 rays that form an angle. Okay, so lots of things that we can learn from an angle. We have what's known as the vertex. Point B here is the vertex. It's where the 2 rays start from. Okay, you have 2 sides. Okay, so you have a vertex. Okay, you have the sides. And look at all the ways we can name an angle. Here's angle B. Notice it has to be the vertex. Then we have angle ABC, 3 letters. So either 1 letter or 3 letters, but it's very important that you know the vertex has to be the middle letter. Okay, and then you have sometimes a number inside here, and that would be angle 1. Okay, so all of those are different ways we say angles. Sides of an angle are the 2 rays, and the vertex is the common point. Okay? All right. Let's get to the next spot. I know we're starting to get a little long, but there's a lot of terminology. All right, adjacent angles. These are important. Okay, so adjacent angles are 2 angles with a common vertex and a common side. All right, so here's your common vertex P, and it says angle QPR. Okay, angle QPR PR. Follow the letters QPR. That's this one. Okay, or angle alpha. Okay, and angle P or RPS is angle beta. They are considered adjacent because they have the same vertex, P, and they share a ray or a side, PR. And if you can tell, they're adjacent because of the lettering, PR and PR or RP. They have to have those two letters in common. With, very important, with the vertex has to be P in this case and P in this one. They have to have the same vertex. Okay? So a lot of different things there with that. All right. The degree of an angle. Okay, the degree is 1/360th of the rotation, or about a point. Okay, remember that if I go all the way around in a circle, we know that that is 360 degrees. Okay, 360 degrees, right? 360. I can't write in this thing. Okay, not with a mouse. All right, so out of 360 degrees, we get degrees out of that circle. Okay, now I am not going to test you on minutes and seconds of an angle. We're not going to go in that depth. You're not going to go in that depth. I do want you to know how to use a protractor, however. Okay, I think it's important that your kids know how to use a protractor. Okay, so if you look here, angle, let's see here. Let's move this up. I'm going to get this out of my way here. All right, so here I have angle B, A, C. That's my angle. Okay, BAC. A is my vertex. This is a 30-degree angle. Okay, I line my ray up here, and then I measure this. You guys should remember how to do this, and I get 30 degrees. Okay, some of your protractors will go like this, 1 through 180. And some of them will actually do the opposite direction for you too. Okay, so depending on the protractors you have at your school. Okay. All right, so let's talk about a couple here. It says find the measure of angle ABC. Okay, actually we're not going to do these because you don't have to do the numbering. So I'm not going to make you do all these. Okay, you don't have to worry about those. I forgot about that. Here's what I need you to know how to do those types of angles. You have what's known as an acute angle. An acute angle measures less than 90 degrees. A right angle measures exactly 90 degrees. Okay, so anything less than 90, 0 through up to 90 is an acute angle. A right angle is exactly 90. An obtuse angle is between 90 degrees and 180. And a straight angle measures exactly 180. A straight angle, when drawn, is going to be a line. Okay. All right, circles and arcs. It's a long section, folks. So circles and arcs. So a circle, a set of all points, you know what a circle is. It has a radius and it has a center. Okay, so we talk about, we have a center O, a point. Okay, now this is not a point on the circle. It is a middle location. It is a center. The circle itself is all of this around, all the points around the center. Okay, so you have a radius. Remember what your radius is. The radius goes from anywhere, the center to any point on the circle is my radius, right? Here we have a radius here, OA. Okay, now we also have what's known as an arc. An arc is a part of the circle. It's curved. Okay, notice it says arc CD, or this little symbol right here with the little arc on top of it, not a straight line. That represents the arc CD. Okay, so you have a radius, you have an arc. Okay, there's also here an arc DA, and the way we do that, DA, and we put the arc symbol. Oop, that's not a very good arc, but there you go. All right, So you have some other things. Diameter. Diameter goes all the way across. It's two radiuses put together, right? A chord. A chord goes from one point of the circle to another point of the circle. Normally not the diameter. Okay? Now, the diameter by definition is a chord. It is the longest chord possible. All other chords are shorter. Hmm? All right, so an arc is a part of the circle can be drawn without lifting your pencil. Okay, we showed you where the circle is. Lift, don't, it's just a weird definition, but a chord is any segment with endpoints on the circle. We just talked about that. Diameter, if a chord contains the center of the circle, it's the diameter, or it's the longest chord. All right, then we have what's known as minor arcs and major arcs. Okay, a minor arc is less than 180 degrees. DC is a minor arc. Whoops, wrong button. All right, so let's talk about this. So DC, minor arc. BC, minor arc, less than 180. AB, less than 180. Okay, a semicircle is an arc of exactly 180. So exactly 180 is a semicircle. Okay, and then we have what's known as a major arc. A major arc is more than 180 degrees. Okay, major arc is determined to be more than 180 degrees. Now notice, a minor arc uses 2 letters, always. But a major arc has to use 3. A, B, or A. Oh, I'm doing the wrong way. Let me do this in a different color. So, follow the letters, A, C, B. So A, I can't go this way because that would go through B, in the wrong order. So A, C, B would go from here through C to B. So this is a major arc all the way around. It's everything except AB. That's a major arc, more than 180 degrees. All right, examples. Now, these are the ones where you start doing some work, okay? So let's start talking about some of this. Let's get back into red here. All right, find the measure of arc AB, okay? Well, arc AB is right here. All right, now, an angle of an arc is going to be the same as the central angle. This is going to be the central angle. So this red and this red are going to be the same degrees. If this one's 60, that means this angle and this angle make a straight angle, which is 180 degrees, which means this has to be 120. So that means this one has to be 120. Okay? This has to be 120. This has to be 60. Okay, now we're going to learn some other things here. You can look here, things you remember, that a triangle equals 180 degrees. So if this is 120, that's 30. This here has to be 30. Okay? All right, so that's kind of what we talked about here. Okay, find the measure of arc AF. Well, here is AF. If this is arc AF, the central angle 60 is going to be 60 degrees. And there you go. See how measure of AF and the measure of the angle AOF would be the same. BC, here's BC. Okay, so one of the other things, and you probably remember, vertical angles. If this angle is 60, that means this angle here also has to be 60. Vertical, they go straight across, it's going to be the same degree. Okay. All right, find the measure of FDC. Well, if it has FDC, that's 3 letters. That's a major arc. Major arc. So DC, F, D, and then all the way to C. Although that's not even a major arc. That's going to be a minor arc because that's going to be less than 180. Okay, they're doing that so that make sure you know which direction you're going. All right, so how do I find this angle? It's going to be the same as this central angle right here, 120. All right, perpendicular lines. Perpendicular lines form a right angle. Okay, notice the different ways. Perpendicular symbol, upside down T, right? A line M and N are perpendicular. Line segment AB is perpendicular to BC. You can even make those lines too. A line perpendicular to a plane. A line perpendicular to a plane is a line that is perpendicular to every line in the plane through its intersection. So if this line is perpendicular, it's going to be perpendicular to all these lines inside the plane. All right, and then perpendicular planes. If P is any point on AD, so here's P on AD, Q in plane alpha, and S in plane beta, so that this line here would now be perpendicular. And then that means the planes are perpendicular. Okay? And if you can prove 90 degrees, you get perpendicular lines. Okay? Dihedral angle, don't do too much with dihedral angles, is formed by a union of two half planes and a common line defining the half planes. Okay? So a dihedral angle is just formed by two half planes. It's a big angle with planes. A dihedral angle is measured by any of the associated planar angles, such as OPD. So if I find the measurement of that angle, OPD, then the plane would have the same angle. And I know there's a lot of terminology. Look through your book. It does do some good job doing the definitions of those. Okay? And I hope this helps. And good luck.